section 15.2. And we're going to look to reduce imperfect radicals. All right, so when simplifying radicals, there are two options. First option is called prime factorization. And what we do here is we look for groups of two of the same numbers, and we write our group outside our radical, and we write whatever's left over on the inside. I'll show you an example in a minute. I just want our notes to be complete, and then I'll show you an example of doing both, and you can decide whatever one works for you. The next one is to find the largest perfect square and separate out. I'll explain what I mean by that in a second. All right, so let's take a look at some examples. The directions are just going to be to simplify. And let's say we had the square root of 18. I'll show you two techniques, and then as we go through the examples, instead of showing you two techniques for every problem, I'll just show you the way I would do it, which I think might be the easiest for you. So the first technique is the prime factorization tree. And what we're looking to do is break 18 down to be all prime numbers. So 2, 3, 5, 7, 11, all prime numbers. So what this looks like is the square root of 18 is the same thing as 2 times 9, which is 3 times 3. The bottom of our trees here are prime numbers. We're looking for groups of 2 of the same numbers. So here's a group right here. What we do is we write our groups outside the radical, and then we write whatever's left over on the inside. That would be the answer. Another way to do this is with perfect roots. Perfect roots would be like the square root of 4, or the square root of 9, or the square root of 16, square root of 25, square root of 36. square root of 49, or square root of 64, square root of 81, or square root of 100. What we're looking to do is we're looking to see which of those, what's the biggest perfect root that we could pull out of the square root of 18. What would it be? Square root of 9. We could write this the square root of 9 times the square root of 2. This was the first rule I showed you in the previous section. Square root of 9 is just 3. We get 3 root 2. Done. This is usually the fastest way. Unless you have a really big number, then you might have to do the prime factorization tree. But you can see we get the same answers. All right, let's try the square root of 250. Now we could do prime factorization. It's 25 and 10, 25 is 5 and 5, 10 is 5 and 2. We have a group of 5s, and then there's a 5 and a 2 left over. So the answer would be 5 root 10. Probably the faster way to do this would be the square root of 25 times the square root of 10, or just 5 root 10. All right, so let's try 2 square root of 25. And let's talk about how to simplify these. Well, the square root of 25 is just 5. That's pretty easy. 2 times 5 is 10. So that one's not that hard. What if we had 3 times the square root of 175? Now, I don't know what perfect root goes into 175, so I'm not going to use the second technique here. But I know 175 is the same thing as 5 and 35. 35 is 5 and 7. So we would just write 5 square root of 7. Remember, whatever's left over goes on the inside. But we're multiplying by 3. The way you multiply radicals is you multiply whatever's on the outside. We would just get 15 root 7. About the square root of 27 divided by the square root of 100. This is the same thing as the square root of 27 over the square root of 100. Square root of 100 is just 10. Square root of 27 isn't perfect though. But I do know that 9 is a perfect root that goes into 27 3 times. So the top would just be 3 root 3. So we simplify the top at the bottom, and that would be our answer. Similarly, if we had the square root of 32 over 121. This is the same thing as the square root of 32 over the square root of 121. Square root of 121 is just 11 And I know that 16 goes into 32 twice. Every once in a while, we might put a negative in front. And in this case, we could just put negative on top. It doesn't matter when you have a fraction where the negative is. Square root of 144 is just 12. And the square root of 20 is the same thing as the square root of 4 times the square root of 5. So if you could easily figure out what perfect root goes into it, it makes things a little faster. So 2 root 5 would be the answer. But we could simplify this even more by taking out a 2 from the top and bottom. We just get negative root 5 over 6. Question? Yeah, because that could simplify even more. You're going to do it the other way. The question was, if you do 2 times 10, is that wrong? This is 2 times 10, but 10 is not a prime number, so you have to keep going. And you get a group of 2 with a 5 left over. What if we had variables? So the square root of x to the 13th. Well, 13 divided by 2 doesn't work out perfectly. So there's a couple different ways we could handle these. One thing we could do is we could write x 13 times. And remember, we're looking for groups of 2. So here's a group. 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 And here's a group. So remember what the rule is. The groups go on the outside, and whatever's left over goes on the inside. So there's 1, 2, 3, 4, 5, 6 groups. And there's 1 left over, or just x to the 6th root x would be our answer. I'm sorry? Oh, it is. Yeah, thank you. It's one way to do it, but if I gave you x to like the 30th, you don't want to write x 30 times. So there is a shortcut. What we could do is convert this to rational exponents. And then just say this is the same thing as 6 and 1/2. And then put the numbers here. Right, so the whole number is how many groups there are. The denominator tells you that it's a square root. And then this 1 is left over. I think that's probably the fastest way to do it. Yeah, so the rule is this. You convert it to rational exponents. So 13 over 2 is the property we talked about, right? 13 over 2 is 6 and 1/2. You just have to try to remember to put the 6, 1, and 2 in the right places. The rule is, if you have something like this, the numbers, letters, variables, whatever you want to call them, look like this. So you just have to try to put the numbers in the right spot. I'll show you another example here. Like if we had the square root of 64x to the 15th. This is the square root of 64 and the square root of x to the 15th. So this is obviously just 8. But when we have x to the 15th, we don't want to write x 15 times. But we could just say this is the same thing as x to the 15 over 2, which is 7 1/2, or x to the 7th times the square root of x to the 1st. So if you can remember that rule and put the numbers where they're supposed to go, it'll make things a lot easier. Does that make more sense now? I have 3 more. Yes, my question. Yeah, so if you have a square root, that's the same thing as just writing it like that. Square root means the 2's there. You don't need it there, though. It's a square root. It's like saying 1x to the 1st. Obviously, you could just write it x, right? It's like the same thing. All right, so I have 3 more left. What if we had the square root of 16x over y to the 12th? Just like before, we could break this up top and bottom. Square root of 16 times the square root of x, all divided by the square root of y to the 12th. So let's kind of take these individually. First one, square root of 16 is just 4. Square root of x, there's nothing we could do with that. The square root of y to the 12th is one of those problems where we could write y to the 12 over 2, which is just y to the 6th. What about the square root of 18m to the 7th? Well, we could write this separately. Square root of 18, square root of m to the 7th. Square root of 18 we know is square root of 9 times the square root of 2. So this would just be 3 root 2. That's what the square root of 18 is. Square root of m to the 7th is m to the 7 over 2, or 3 1/2, which, putting the numbers where I told you, would be m to the 3rd times the square root of m to the 4th. Way you would write your final answer is we write everything on the outside. So this would be 3m to the 3rd. Then you write everything on the inside, so square root of 2m. And like we talked about, you don't need to put a 2 here. You can if you want, but if you don't write it, it's automatically a 2. One more problem tonight is the square root of 11 y to the 7th divided by 49 x to the 4th. This is really 4 problems in one. So we could separate this to be the square root of 11, square root of y to the 7th, over the square root of 49 times the square root of x to the 4th. Square root of 11 we can't change, so that's fine the way it is. Square root of y to the 7th is the same thing as y to the 7 over 2, which is the same thing as 3 1/2. or y to the third times the square root of y to the first. Yeah, we're just kind of going step by step here. So eventually we are going to combine them. Right now, we're just keeping everything separate. Square root of 49 is 7. And the square root of x to the fourth is the same thing as x to the 4 over 2, or x squared. What this turns into is just y to the third times the square root of 11y divided by 7x to the second.